Hey everyone, my name is Seturaman, co-founder of Web3 Compass, and welcome to Build with Stylus. Now, this series is here to help builders jump into the Arbitrum ecosystem using languages you already know and love. With Stylus, Arbitrum makes it possible to write smart contracts in familiar languages like Rust, C, C++, Go, and more. That means faster iterations, cleaner code, and an easier path to getting your ideas on chain without having to deal with Solidity. Every episode in the series is practical and hands on. We will guide you step by step from setting up your environment to deploying your very first Stylus app on Arbitrum. Now, this whole thing is part of Namaste Arbitrum, an initiative focused on growing the builder ecosystem here in India through education, community, and real world projects. So, if you're ready to build, experiment, and ship, let's get started. All right. So in this video, we are diving into yet another frontier in the world of Stylus, the Go SDK. Yep, the same language that powers Kubernetes, Docker, and half of the cloud. You can now kind of use it to write smart contracts on Arbitrum. But before all that, let's just back up for a second. If you have been following our Stylus journey, you already know the big picture. With the Nitro upgrade, Arbitrum added a WebAssembly-based execution engine, and that's what made Stylus possible. And Stylus opened the door for smart contracts in Rust, C, and now Go. But Go is actually a bit different. You see, Rust and C on Stylus were kind of expected. They were low-level system-first languages that mapped really well to WASM. They gave you fine-grained control over memory, no garbage collection, and a very minimal runtime overhead. And that's perfect match for WebAssembly, which is designed to be fast, portable, and deterministic. In fact, WASM was practically made with languages like C and Rust in mind. You can manage memory manually. You know exactly how your data is laid out. You can optimize for performance and size. And because there is no hidden runtime, you get a very predictable behavior, which is crucial for something like blockchain. But Go is built very differently. It's actually a higher level language. It has a garbage collector. It has a rich runtime that does things behind the scenes, like, managing Go routines, handling scheduling, and abstracting away memory management. That's part of what makes Go so easy to work with, but that's also the part that makes it harder to compile Go down to a tiny self-contained WASM module. To put it simply, Go wasn't designed with WASM in mind. It was designed for modern backend systems and not for running inside a deterministic stack-based virtual machine like Stylus. So then the question becomes, how does this all work? Well, two words: TinyGo. So TinyGo is a lightweight Go compiler designed for smaller environments like microcontrollers, WASM runtimes, and now Stylus. It strips away all the heavy stuff and compiles Go to WASM and makes it lean enough to run in places the regular Go toolchain never could. And that's actually the secret sauce. And thanks to an experimental SDK by the community, we can now explore what writing Go smart contracts could look like. Now, to be very clear, this is more of a proof of concept. It's not something that lets you compile or deploy contracts yet. The SDK isn't actively maintained, there is no official support, but it's an early glimpse into what Stylus could eventually enable for Go developers. There is an example contract that comes with the SDK called foo contract, which defines some basic data fields and a few methods to go along with it. Now, all of this is written in regular Go. It's not runnable yet, but it shows that with the right tooling and support, smart contracts in Go could feel pretty natural and familiar. So now there are quite a few challenges around this whole thing. I mean, Go's runtime and garbage collection makes it hard to compile it to WASM. Tools like TinyGo does help, but comes with big limitations like limited standard library support and quirks around type conversions. And since Stylus contracts run in WASM sandbox, you can't rely on Go system calls and stuff like that. Everything has to be deterministic and compatible with the execution environment. So as of now, the Go SDK is pretty rough. It lacks docs and working compilers, but it does prove a point that the stylus architecture is flexible, that even a high level language like Go can start to be mapped onto it. So what does this mean? So if you're a Go developer, it means that the doors aren't completely closed. You might not be writing production level Go contracts tomorrow, but down the line it's totally possible. And with Stylus supporting multiple VMs, it's not far fetched to imagine Go contracts sitting right next to Solidity ones, sharing states, calling each other, and composing new kinds of dApps. So while this SDK isn't ready for real use, it's exciting. It's actually a spark, a rough prototype of what's coming. So yeah, Go on Stylus is not build ready yet. What it shows is there are a lot of possibilities, and those possibilities might come way sooner than we expect. So let's get to building. So if you guys want to go ahead and explore the repository, all you have to do is Google Stylus Go and it will take you to this repository. Now, as I've already mentioned, this is not an official repository from Offchain Labs. This was actually made by a member of the community. I mean, there is an actual blog, there is a full-fledged blog that explains the whole process that he used, like his approach and everything. So if anybody is interested to contribute to this repository or even try and add new languages to Stylus, I think this is a great starting point. Like, it's very detailed and explains the whole process. Again, the repository is not actively maintained. As you can see, like, the last commit is almost an year old, but you can still explore the repo. Like, I've already mentioned that it comes with a basic contract. Yeah. So it's a very simple contract with a few data fields and a few functions, like putting out the name, a basic transfer function, and all those things. But again, this is how a contract in Go is going to look like, right? So you guys can explore this repository, maybe play around with the contract and stuff. But in order to do that, make sure you have TinyGo installed in your system, right? Now, it's a pretty straightforward installation. They have guides on how to install TinyGo on various operating systems. Along with TinyGo, just make sure that you also have the LLVM installed. Like, in our previous C++ SDK video, we talked about LLVM and how it helps with the format conversion, right? Like C code and etc. to WASM. So you need LLVM here also, like, in order for the conversions and stuff. Again, along with LLVM, you also require the WebAssembly toolkit, binary toolkit. You can directly go to the repository and install it. Yeah, it's pretty straightforward installation. So once you have all that, you can go ahead and play around with the SDK. Like, you can try to compile it, build it, and everything. Like, all the instructions are pretty clear. Like, there is a build.sh that you can use to try and build the contract and deploy it. But I believe a couple of parts are broken or missing. But again, the repo is open to contribution. So if there is any Go developers, please do connect with the contributor, like the core maintainer of the repo, and maybe you guys can bring this SDK live, right? So yeah, so that's it. Again, this video explores the potentials or the possibilities that are coming with Stylus, like all the languages, all the different languages, all the more complex applications that you can build, everything. So do explore, do try it out. And in case there is any questions, I think the Arbitrum ecosystem is pretty live and active. So you can always find answers there. All right. So that's it for this episode of Build with Stylus. Keep learning, keep building, and also follow Namaste Arbitrum and Web3 Compass on Twitter for more guides, support, and updates on all things Web3. See you in the next one.